Alright guys, I told you I would show you how to do electron configurations in the easiest way using the periodic table. Remember that there are several things to consider about the periodic table. These first two columns, they're called families or groups, they are considered the S block. So we'll write that on here. So the final electrons for each of these elements are going to be in the S block. This section here, these 6 families, except for helium. Helium is actually part of the S block, so we can just put this over here. So helium is going to be over here now, and this is considered the P block. These inside 10 families, this is the D block. And the two periods, or these two rows, these are considered the F block. Oops. Okay, and that's just going to make it a little bit easier to do the electron configuration for each of the elements that we're going to look at. Keep in mind that every single s orbital, or every orbital can hold 2 electrons, but there's only one type of s orbital, so there's going to be a maximum of 2 electrons. There's 3 types of p orbitals. That makes it so that you can have 6 electrons, so that E with a negative is electrons. The D block, there's 5 different types of d orbitals, so we can have a maximum of 10 electrons. And with the F block, since there are 7 different types of F orbitals, we can have 14 electrons. When we do electron configuration, we're really just looking at what is the sequence of orbitals that is getting filled for each element. And keep in mind that there is a rule saying that the lowest energy level always gets filled first, and that was the Aufbau principle. Aufbau was the one who said that that the lowest energy level orbitals are going to get filled with electrons first. And there are some exceptions to that rule, but we're not going to go into those right now. So as you go through looking at this periodic table, you need to consider the different rows. And the rows are actually called periods. That's why it's called the periodic table. So this first row is row 1, second row is 2, third is 3, all the way down to the 7th row. Now, I want you to be very aware that these 2 periods are actually within the periodic table in here. So if you look, here's 57, here's 58, all the way to 71, and it picks up with 72 here. So these two sections, or this entire F block, really kind of fits into this part of the periodic table. So just keep that in mind. Now, when you're trying to figure out the electron configuration, there are 3 parts to each number and letter sequence. So let's say that we have 1s2. The 1 is the energy level, and that's what you get from here, these period numbers. The S is the orbital. So which orbital are we talking about? What kind of orbital is it? And the 2 here tells you how many electrons are in that orbital. So if I'm looking at an element that has 1s2 for its whole electron configuration, that 2 tells me exactly how many electrons that element has. And since we only do electron configuration for neutral atoms, it must have the same number of electrons as it has protons. And the only element on the periodic table that has 2 protons is helium. Now remember, we moved helium from here to here. It still has 2 protons. Okay. So let's look at another element, and I'll show you how I go through the process of determining its electron configuration. So I'm going to look at nitrogen. So it's number 7 right here. All right. We're going to start with the lowest energy level orbitals first, and those are the 1s. So we're looking at the very first period, and the very first block. So the first energy level orbital that's going to get filled is the 1s orbital. So for nitrogen, we start with 1s, and that orbital is going to get completely filled. We have 7 electrons here, 7 protons, but again, if it's neutral, there's also 7 electrons. So we start with 1s, and since it gets completely filled, and we know that an s orbital can have 2 electrons, we're going to have a 2 up here. So that's 2 electrons, but we have 5 more, so where are those 5? We have filled the entire first energy level. Now we go down to the second energy level. So, and the first orbital that gets filled in the second energy level is the 2s orbital. So now we're writing 2s. And keep in mind, the maximum number of electrons in those s orbitals is 2. So we have 2s2. That gives you a total of 4 electrons, and you have 3 more. So this entire energy level is not yet filled. We also, in addition to the 2s orbital, in the second energy level, we have the p orbitals. And remember, the maximum number of electrons in the p orbitals is 6. However, we don't need 6. We only need 3. So what we write here is 2 for the energy level, p for the types of orbital, and 3 for how many electrons we have in those p orbitals. When you're checking your work, check to make sure that you have 7 electrons. If you're doing the electron configuration for nitrogen, you should have 7. So 3, 4, 5, 6, 7. All right. Let's try another one. Do this one in blue. Let's do calcium right here. It has 20 protons. Therefore, as a neutral atom, it should have 20 electrons as well. And we're going to start the way we start every single time, with the lowest energy level orbitals. So we start with 1s, and it gets completely filled, so it has 2 electrons. Then we go down to the next energy level, so that's the second energy level, and we've got the 2s orbital that also gets completely filled. And then we have the 2p orbitals that also get completely filled. So we have 2p, and keep in mind that maximum number for the p block orbitals is 6, so we have 2p6. Now we have filled that entire second energy level, so we move down to the third. So now we have 3s, 2, filled it up. And then we have our 3p orbitals, and that gets filled up as well. And now that the third energy level is filled up, we go down to the fourth, and we have 4s. And notice that if we were doing potassium, number 19, it would just be 4s1. But since we're doing calcium, we're going to do 4s2, because you need that entire orbital filled, so 4s2. And just to check, 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, and that's how many electrons we have. So this right here is the electron configuration for calcium. Okay. Now, things get a little bit more difficult once you get into the D block and particularly the F block. So I've already said that when you are at this energy level, this number in front is going to be the same as the energy level. That is only true for the S block and the P block. Okay, so if you're looking at this orbital here, this is the 2s orbital. If you're looking here, this is the 3p orbital because it's in the third energy level, and it's in the P block. The D block is different. Let's say that the energy level is N. For D, it's N minus 1. So while this section of D orbitals is in the fourth energy level, we call them 3D. Same thing for this next one. Even though this row is in the fifth energy level, it's 4D. So for all of the D block orbitals, it's one less energy level. It's one lower energy level. And that really has to do with how the electrons are now kind of backfilling some empty spaces that were left when those s and p orbitals get filled. Now, the F block is similar, except that now it's n minus 2. So even though this is in the 6th energy level, these electrons are actually going to go back, and well, they're going to backfill the 4th energy level. So this is 4F. Even though this is in the 7th row, this is going to be 5F. So watch the next video and I'll show you an example of how to determine the electron configuration for a more difficult element.